In this video, I'm going to be working free response question 4 from the 2024 AP Calculus exam. So they're going to give us a picture of the graph of f, and they're telling us it's differentiable from -6 to 7. It's got a horizontal tangent at -2, and it's linear between 0 and 7. Cool. So R is the region in the second quadrant, and region R has area 12. Okay, I see what they're doing. They're going to tell us that g of x is the integral from 0 to x of f of t dt. We want to find the values of g of -6, g of 4, and g of +6. So this is just kind of like a geometry integration theory type question. So I'm just going to start with g of -6, and that's going to be equaling the integral from 0 to -6 of f of t dt. And that feels kind of backwards to me, so I'm going to switch the bounds of integration and make this negative. Okay, they told us that the area of region R was 12, so the integral from -6 forward to 0 of f of t dt, that is going to equal 12. Okay, so I'm going to say this is the negative of 12, and maybe I can just write that right there. Okay, that's -12. Then g of 4 is going to equal the integral from 0 to 4 of f of t dt, and that's something I'm going to need to find with geometry. Okay, so 0 to 4 is going to be this triangle here, so that's 1/2 times the base times the height. Okay, the base is looking like 0 to 4 right here, that's going to be 4, and the height is 0 to 2, that's right there, and that's not something we're going to need to simplify. Okay, and then g of 6 is going to equal the integral from 0 to 6 of f of t dt, which is going to start off the same way. I mean, it wouldn't be too hard to say half of 2 is 1, so it's just going to be 4. But just to show you what I'm thinking here, it's that first triangle right there, and then we're going to need to add the area of another triangle which has width 2 and height -1. So I would say plus 1/2. Base is 2, height is -1, and that will be an exact value, and we can just walk away at this point. So move on to part B. Okay, part B, we're going to find all values of x on the interval 0 to 6 at which the graph of g has a critical point. Okay, now remember g is the integral from 0 to x of f of t dt, so g prime of x is going to equal f of x. Okay, so that'll be important if we're looking for critical points, kind of like in number 3. So g prime of x equals f of x. I'm going to just start with that. Remind the reader that I know exactly what's going on here. I know what they're getting at. Okay, g will have a critical point anytime g prime of x, which is equal to f of x, equals 0. Okay, and that's happening at x equals 4. Find all values of x where there's a critical point. They didn't tell me to do anything else. Okay, so I'm just going to say, okay, that's my answer, x equals 4. The reason is what I wrote up above, g prime equals f, so that's when g's derivative is equaling 0, that's going to be a critical point. We could also have g's derivative non-existing, but I don't see f non-existing anywhere between 0 and 6. Okay, so that'll be fine. Done with B. Moving on to C. H is the integral from -6 up to x of f prime of t dt. Okay, now that's interesting. I don't think it's going to be bad or anything. We're just going to need to keep our cool. I don't know that I've ever given my students one of these where we took the derivative of one where the integrand was a derivative. It's a good idea. I like it. Okay, so h of 6, I'm going to start with that. H of 6 equals the integral from -6 to 6 of f prime of t dt. Okay, this is an integral we're going to want to take with the fundamental theorem, right? This is going to be f of +6 minus f of -6, which is going to be equal to, okay, f of +6 is -1, that's why they put that on the graph, minus f of -6 is 0.5. Okay, I was kind of wondering about that. Okay, h prime of 6, well, if h of x equals the integral from -6 to x of f prime of t dt, just in case you forgot, you could say actually h of x equals f of x minus f of negative 6, like actually take the integral like I did there, and then take the derivative and say, okay, well, h prime of x equals f prime of x. Okay, but, or you could just do it with second fundamental theorem like I typically do in my class. Okay, so h prime of x equals f prime of x, and so h prime of 6 is going to equal f prime of 6, which equals, okay, the slope there, okay, I'm going from this point to that point. Slope is going to equal rise over run, so I rose -2 when I ran force, that's -1/2 there, along that line. So it's going to equal -1/2, and then we want to know h double prime of 6, so I'm going to say h double prime of x equals f double prime of x, and that's going to have to equal 0 because f is a linear function. And it didn't really say justify, but I'm going to write it anyway, because f is a linear function. Okay, now I'm realizing they asked for h double prime of 6, so I'm just going to say h double prime of 6 equals 0. No drama, move on. All right, oh, that's all for number 4. So that's going to be all for this video. Thanks for watching.